The physicist was Miguel Alcubierre, and he came up with a theory that rocked the scientific community worldwide in 1994. Alcubierre was doing his PhD research on Einstein's general theory of relativity when he saw an episode of Next Generation where heavy masses can curve space and time. So Alcubierre picked up a scrap of paper, did the calculations, and laid the foundation for an article that appeared in the Science magazine later that year. In his paper, Alcubierre describes how to compress space and time in front of a spacecraft and stretch it back behind the ship to travel a much shorter distance to the desired destination, safely trapped in what he calls a torsion bubble in visualization. However, there is a problem with Alcubierre's warp bubble. You see, the warp engine is difficult to make in reality. You can't just aggressively curve space with normal mass. You need exotic matter with negative gravity. Alcubierre's warp drive would function by enclosing the spaceship in a bubble of flat space-time and twisting space-time around that bubble to shorten distances. To work, a warp drive would need either negative mass, a theorized type of matter, or a ring of negative energy density. But because physicists have never observed negative mass, we are left with negative energy as the only option. To generate negative energy, a warp drive would require a massive amount of mass to create an imbalance between particles and antiparticles. For example, if an electron and an anti-electron appear near the warp drive, one of the particles will be trapped by the mass, resulting in an imbalance.